Alrighty. Hello everyone, and let's get started. Bit of a late start, just waiting for people to trickle in as the lesson starts. So this is going to be Pong project, mini project part 2. And last week, if you don't remember, we went over the basic idea of classes and objects. And classes and objects, it's kind of an abstract concept until we go ahead and actually use it. But hopefully my explanation last class was able to kind of help you understand how the classes and objects kind of worked. I know it's a little hard to understand at first, but hopefully with practice and after you're able to review over the example code that was sent, it was much easier to understand for you guys. So the next thing, or the next step in approaching these kinds of problems is going to be learning how to actually implement classes and objects into a usable scenario that actually needs the use of a class and object. If you're looking for any practice exercises yourself, I recommend what you go ahead and do is you use Google as a source of as a source to basically find these types of projects. So if you go ahead and search up class and object examples, so you will see a lot of different websites that will give their own examples. Usually the first one is pretty good. So over here we can see it gives us a bunch of exercises, so that's really just teaching us. So let's look over here. So this is going to be, I believe, very similar to the example we looked at last week, talking about dogs. So we have our public class puppy, and it has like its certain definitions inside of it. I believe this is Java, not Python, but that doesn't really matter for now, as we are just looking for the concept. So we will go ahead and we are going to do this ourselves. So alright, so we're going to go ahead, make a new file. We're going to name this, say, class and object v2. So it's a Python file, and what we notice is, first thing we can do is we can actually just go ahead and copy and paste this in. This kind of gives us a sort of a template to base off of before we go ahead and make our changes ourselves. So what we go ahead and we do over here is we want to get rid of these extra methods. So every single method in here is specific just to the car class, but we are making a dog class. It's not a car, right? So when we go ahead and we define our class of dog, it's important to know kind of what is the goal, right? So the goal this time is just to create something where it matters how the object is defined, and we will see exactly how this is implemented later on, but for now we just want to make sure we get down the basics of how we can go ahead and write a class and object. So the very first step is going ahead and defining our class, and the way we do that is we literally just write class and name. So class and name, right? And then we make sure we have to write define underscore underscore init underscore underscore with self and all of the values that we're going to be inputting, right? And this is important because when we go ahead and we create an object, it has to have this number of input values in order for it to make sense. Otherwise, we'll have objects with different input values and it all gets very confusing. So there are some special names to some of the references within these, I guess, these classes. So first off is something known as a class variable. A class variable is a variable that can essentially be accessed anywhere within the class. And we will just define this variable as say happy, and happy will always be equal to true. So happy can be accessed anywhere within the class, and it is always defined as true. So when we go ahead and we make our object here, no matter what kind of dog it is always going to be a happy dog, right? Now, we go over here, obviously dogs don't have brands, instead we'll say they have breeds, right? So we do self.breed is equal to breed, and this is just a standard way of defining it. It's important to note that these two have different values, which is why you have to assign the values here. What's happening is essentially this method is taking whatever you inputted when you created the object. Say you were to make an object called Bob. Okay, so Bob is going to equal to a new dog, and actually it's just dog, yeah, dog, and it's going to be big, it's going to be golden, and its breed is going to be, say, a golden retriever, right? So we never defined whether or not it was happy in here, and that's because it is always happy. Now, inside this method here, we notice that there are three different things, and if I were to write them down, they are size, color, and breed. Well, size, color, and breed, alright, well, let's just reference them to each other. So size is big, color is golden, and breed is golden retriever. That is how we go ahead and we determine the order in which these values are passed in. Now, once we go ahead and we actually pass in these values, they aren't part of the class or the object quite yet. And the reason for that is because, well, all it is a value that we put in. It hasn't been stored anywhere yet, right? Which is why we go ahead and we do self.size is equal to size. So what self.size is that it's essentially a variable that is specific to the class. And you can access the value of self.size wherever. It's important to do self.size because essentially what the self is doing is it is referring to the object itself. So instead of thinking of self, think of it as bob.size. So Bob's size, Bob's color, Bob's breed. So that is why we go ahead and we use self, because otherwise what's happening is we just have these parameters that are passed in, but they aren't being stored anywhere. So this is the storage process, and that's why it's important to make sure we know exactly what is going on in this method. This is probably going to be the one method that is needed in every single one of the classes, no matter what kind of class you're making, because this one allows you to create your object in a fast and efficient manner without creating much hassle, and it's a standardized form, pre-written. The instructions are there for you. There's nothing else that you kind of need to throw in to make it work. So the init function is very important to learn. I suggest you familiarize yourself with it. Use some different variables. Again, you can even go ahead and make this with 5e's, and now all you have to do when you pass it into size is this is 5e's, but this still has 1e, because these two are different variables. That is something that can be very confusing amongst beginner programmers because, well, you know, they have the same name, so naturally we think they are the same variable, and we kind of ignore this prefix at first because, you know, why are they different? It's just, you know, maybe some side text that doesn't really matter. Well, unfortunately not. It's really important, and it allows us to, it notifies us that it's a part of the object's identity, and we need to modify the object's identity when we receive new information. The next method that is really important in classes is known as the main method. The main method usually has no parameters here, so none of these dudes. Instead, we will just have self. Now, the main method can be placed anywhere. It can be placed outside the method, so we can have a define main over here. And that would be perfectly fine. Notice how we do not have a self in here because self refers to the object and we do not have an object at hand here. Instead, if we were to go ahead and need an object, we would go ahead and define, and we would actually go ahead and just put Bob in here like that. But, you know, there's no use for that right now. So we don't really need a main method right now. It's just another one of the methods. Instead, we will go ahead and make a method called bark. And now when we go ahead and we define our method bark, the only thing that we will ever need in the parameters is going to be self. Except when we do need to access a variable that is not defined as an object variable. Instead, it could be a class variable, right? Or it could be a variable from some other place that's, you know, not stored within the object, right? The examples of those will come up later, but for now, we would just keep it simple with just self. So, when we go ahead and we define bark, there's many different ways we can do it. First way is we can just go ahead and print bark. It's plain and simple, but what's not good about this is it doesn't matter what size of the dog or what's the color of the dog or what's the breed of the dog. It is simply always going to bark. So instead, I want to go ahead and test. I want to test whether or not it is going to accurately tell me whether or not it's going to bark based off of certain physical attributes of our dog. Now, there are two different variables here. We have our class variable and we have our object variables. So I'm going to create an if statement based off of both of them. So first way we can do it is we can say if happy is equal to true, then we can go ahead and print bark. There we go. So make sure you add this in here because it is not a part of the object variable, right? So if happy is equal to true, then we go ahead and print bark. One thing we can do is we can actually delete this. And the reason why we can do this is because the natural way the if statements are written is in order to just check if this statement is true or not. That is the default appearance of the if statements. Now that we've checked if it's happy, if it is indeed happy, then we'll bark. So if we are to run this and we want to call our method bark, we will get that. Oh, that's right. We will see that it does bark. And you'll also notice one thing, that we have happy defined here. So if we were to go ahead and, you know, define this as false, then it would go ahead and print bark as true, right? So another thing we can do is we can just delete that entirely. And the reason why we can delete that entirely is because we define it here. And once we define it here, it is no longer needed to be redefined, I guess, within the class. So if we were to run this again, we can see that it still barks. Now, how do I know it's just not automatically printing bark? Well, we don't really know that. And that's why we can go ahead and actually debug it by just going ahead and printing happy. Just to know, oops, no double quotation marks, printing happy. And that allows us to know whether or not it is actually following what we want it to. And we can see that it is because, well, happy is printing true, and it then follows through the if statement properly. Right, that is the step that we want it to follow. Next thing is we want to go ahead and check, alright, what happens if I don't want to use happy, right? What happens if I want to use, say, the size of the dog, right? So if size is equal to big, so I forgot to put the self dot there, then we can go ahead and print bark. So it will only bark if its size is big. And we can see that it still goes ahead and barks. Right? We still fed in the true, but it's no longer using that true. But I want to use both of them. So what we can do is we can add an and here. And we can add that statement as well. So if this were to be false, so let's just run it if it's true, it will bark. But if we change this to false, it will not return anything. So I don't like that it doesn't return anything when it doesn't bark. So instead I will go ahead and say print I don't want to bark, right? And now we can see it says I don't want to bark. Even though its size is big, it does not fit this second requirement of happy within this if statement. So we have been able to go ahead and create this, instance of our method that we can go ahead and implement. Now the next stage is just going ahead, seeing other people's codes for Pong and trying to see and implement them ourselves. So I'll give you guys about 2 minutes to absorb what's happening over here, and then I will go ahead and move on to the next stage, in which I will show you some of the example codes online that I believe are good examples of the codes we can use for Pong. Alright, now we can move on. So I will go ahead and display this over here. So if we were to go ahead and just Google Pong code Python, doesn't matter in which way order you say it, as long as you say Pong code and Python, you will get some pretty good options that appear. Well, we can go ahead and check out every single one of these, and just see if we like what's going on, I guess, right? Because we want to make sure that whatever's happening, we fully understand it, right? That's the most important part. So we click into the example, and we can see, alright, so this is Geeks for Geeks, pretty trusted website. So let's look through it. Alright, I see. Python 3. This is an example here, and what this is it's essentially just creating our paddle and ball. So that is what it would show us. So I want to see, oh, does this work? How do I check this? Well, I do it myself, right? So we're going to go back to here, and we're going to enter pie chart, and we're going to create a new one. And, oops, right here. We're going to create a new Python file. It's going to be called Pong test. Alright, we'll paste the code here, save it, and we want to run it. We want to see, does this work as promised? And we saw for a split second there that it did in fact show it. It didn't show it for very long, but it did in fact show it. So we can see about like half a second maybe, really short amount of time, but in the end it does in fact show us. And that tells us, alright, it seems like this is kind of trustworthy. Well, why does it not show us for longer? You know, why does it suddenly exit out? Well, I don't see throughout this code there's any signs that it will automatically exit out. Why in the world does it exit out? Well, the reason is actually fairly simple. It's because in order for the canvas to hold that frame for long enough, you actually need to tell it to hold that frame for long enough. It won't automatically do it for you. So, what in the world do I mean by that? Right? Well, essentially, every single time you see a new frame, what's happening is it's not that your screen is like moving or something like that. Your entire screen is actually reloading, and each pixel on the screen is displaying a new color if there is a change in what is appearing. So what's happening in the pawn is it's essentially displaying exactly one frame of whatever this this code is drawing for us, and it will not sustain that one frame because we simply did not tell it to sustain that one frame. So hopefully that makes sense to you. It's a little bit abstract, not really something that you entirely need to understand, but it's just something cool to know. So the next part, they go ahead and expand upon it, and they tell us, alright, so below is the complete Python program to create Pong game using the turtle library. So that's a fairly long bit of code, and they have a little video here so we can go ahead and play it. And this video shows us what we should expect from the game that they have created, right? And when we go ahead and we analyze this, there are a couple things that we can go ahead and see and check ourselves, which we will go ahead and do next class when we go ahead and take a closer look at the code. For now, all we need to do is just go ahead and copy this code over here. So you can do that, or you can just press copy code, which is right over here. It's usually going to be like a paper symbol. So we're going to go back, we're going to flip to this, and we're just going to do Control-Alt, Control-V. And you'll see, oh, well, it seems that we have some errors. What's happening? So if we are to go ahead and do this and run our Pong test, it will give us an error that we, or actually it just tells us invalid syntax. But the real problem is that we do not have turtle imported, right? So there is an import required for this library. Now, I'm not going to go ahead and teach how to import an entirely new package this class, because that would be a pretty hefty step, moving on from classes and objects and then importing a new package. So we will stop here for now. Instead, we will just do a brief we will do a brief look over of the code. So we look at this code, and this first part over here is just displaying our what we should be looking at, essentially. It puts everything in its original place, how it should look at the very beginning. So that's what it should look like. That is all this entire bit of code is showing. Believe it or not, a lot of stuff, but you know, it's just showing and explaining some pretty simple stuff, right? Now, here comes the trickier part, our definitions. So the definitions here, or the functions or methods, give us 4 different movements. These movements are up, down, and up, down. Well, wait, usually isn't it up, down, left, right? Well, this is Pong, unfortunately. We may be able to implement our own up, down, left, right later on. Who knows, right? It could be in our own variation of the game. But that is all something that we can go ahead and, test for ourselves once we truly understand what in the world is going on. Now, we see this, and we think for a second. There's 2 up-down functions. It sounds like I can go ahead and make this shorter. Now, for you guys, it's probably not something that comes very easily to you, because it's not something that you've done, it's not something you've practiced before. As someone who has gone ahead, programmed using classes and objects quite often, this is a classic use to implement classes and objects. We have 2 of the exact same method with one and only one difference. The only difference being that this variable is different. In here it is left pad, and in here it is right pad. We can go ahead, shrink this down by half. And suddenly, when we look at this code, it has shortened itself by a good probably 10% already in our first implementation of classes and objects. And the more methods we add on, so we add a left and right, then instead of adding 4 methods, we're only adding 2. If we are to go ahead and add a scoring method, we are only adding 1 method instead of 2. So these are all ways that it's important to really understand how helpful classes and objects can be. And the more additions we add, the more you're going to learn to appreciate the beauty of classes and objects and how using them can simplify your code to measures that you did not even know existed. Of course, the jump from coding BAT into classes and objects is a little bit of a big jump, and I perfectly understand if it's something that you don't quite get at first because you haven't actually gone ahead and programmed long programs yourself. The tic-tac-toe program we wrote was about maybe 100 lines of actual code and 100 lines of comments to explain what was going on. Another, that's not really a good example, really, of a long piece of code. Long pieces of code usually have really long methods. There's a lot of different things happening, and it really doesn't make sense to use classes and objects until much later in your programming careers. But it's important to learn this at first in order to not make that mistake of, copy and pasting your code, when in reality you can actually make it super duper simple by just making a class and creating the objects. So with this brief little roundup of information, I don't have anything else for this class. In the next class, we will be moving on by creating our first rendition of Pong, just using code from online, just showing the steps that you guys can take in order to complete your own projects. It could be a game that's not Pong. It could be like Connect 4. It could be chess. It could be checkers. It could be Go. It could be any game that you can display, right? But the goal of this mini project is just to show you the steps you take in order to advance your programming skills. So, if you have any questions, feel free to ask them. If you don't have any questions, thank you for watching, and I hope you guys are willing to go ahead, Google the different programs yourself, see if you could just copy and paste them and see if they work inside your own programming IDE. I'm sure you're going to find some programs that aren't going to work, because it's not like necessarily a foolproof program for each one of the resources that you'll find. But I'm sure you'll also be able to find at least one that is working. So with that, thank you for watching, and I guess I'll see you next week.